The lecture is about COVID-19 testing laboratory, specifically the Rtpcr laboratory, the planning and design in the Philippines. So my firm is Arbuena Architects, who offer comprehensive architectural engineering services. So our expertise is healthcare, academic research, and laboratories. And our design philosophy is always pursue to produce excellent, high quality work, completed on time and within budget. We give emphasis on function, maximize use of space, flexibility, client needs, and the use of environmental friendly materials that are durable and economical. And we believe in timeless architecture in building design, creating architecture that will generate equilibrium with the people and the community. So our learning objective for this topic is the COVID-19 virus overview and the design basis international and local guidelines. And we will discuss the design principles and the biosafety standards. For the part two, we will be discussing the laboratory design standards and the RT-PCR reverse transcription polymerase chain reaction facility and workflow, and RT-PCR sample architectural designs. So we have two-part, like this is a two-part lecture. So the coronavirus is an infectious disease caused by a newly discovered coronavirus. Most people infected with the corona-19 virus will experience mild to moderate respiratory illness and recover without requiring special treatment. Older people and those with underlying medical problems like cardiovascular disease, diabetes, chronic respiratory illness, and cancers are more likely to develop serious illnesses. The best way to prevent and slow down transmission is to be well informed about COVID-19 virus, the disease it causes and how it spread. Protect yourself and others from infection by washing your hands or using alcohol-based rub frequently and not touching your face. The COVID-19 virus spreads primarily through droplets or saliva or discharge from the nose when an infected person coughs or sneezes. So it's important that you also practice respiratory etiquette. For example, by coughing using inflexed elbow. So cover your nose or your mouth when you cough. At the time, there is no specific vaccines for treatment, but this was last year. But we have now vaccines. And for COVID-19, however, there are many ongoing clinical trials evaluating potential treatment. Okay, so based on this slide, no, this slide was presented last year. So that at that time there were no, there's not there. They are still on the process of creating vaccines for COVID-19. Right now, we have several vaccines available, and in the Philippines, I think we have 4 vaccines that are FDA approved. So the coronavirus started on December 2000, on 2019, December 9. So the first patient developed symptoms in Wuhan, and China alerts the WHO on December 31, nearly after a month, no, nearly before 1 month, no. So then Wuhan, the market was shut down after a month, and then the identification of the new virus COVID-19 was released on January 7. So the sequence was released on January 7 and it was available worldwide. No? So that was the time when when scientists started to study the virus and started to create vaccines and treatment for the virus. That was January 7. And January 11, nearly after a month, no, the first death in China was recorded. Then the first outside of China in Thailand was recorded on January 13. Then Wuhan was placed in quarantine on January 23, and then death toll climbs to 132,000 in January 29 of 2021. So that was a very fast uh, spread of the disease, no, worldwide, no. So it spread too fast that it was beyond the control of nations. So in the Philippines, at that time, that was August 8, 2020, when this was last presented, this lecture. Philippines is about 57,559 cases. No? Right now, we have at least, I think it's at 600,000 cases. No? From August 8 or 57, now it's 600,000 cases. So last yesterday, we had at least about, I think about more than 8,000 cases yesterday. So what is a risk group classification for SARS-CoV-2 under the NIH guideline? I'm discussing the risk group classification because we will be discussing the way on how to design the laboratory. And designing a laboratory, you need to identify what are the risk group or the risk group classification of the virus that you will be handling. So in Appendix B 2D of the NIH guideline, April 2019, SARS-CoV-2 and MERS-CoV SARS-CoV and MERS-CoV are listed as risk group 3. So SARS-CoV, okay, at the present time, SARS-CoV-2, which best meet the definition of RG3 agent, and IBCs consider the agent as risk group 3 as a starting point at the risk assessment when reviewing research subject of the NIH guideline. So SARS-CoV-2 is under risk group 3 agent. SARS-CoV-2 is the virus of COVID-19. So NIH guidelines define the risk group as risk group 3, which is SARS-CoV-2, agents that are associated with serious or lethal human disease for which preventive or therapeutic interventions may be available. So it means that you can get well when you get coronavirus, but there is a high risk to an individual, but the agent represents high risk to an individual, but a low risk to the community. So it may infect a lot of persons, but not all of them will die. So I think the death percentage is about less than 2%. So maybe 100 people will get infected, maybe less than 2% will die. Okay, so that is why it's under risk group 3. But if it's under risk group 4, the death percentage will be higher. Okay, so it's not under risk group 4, it's under risk group 3. So in managing a virus, there are different hierarchy of controls. No? There are ways to control the spread of the virus. Okay, in your laboratories or in your community. Okay, so this is the hierarchy of controls that we commonly use, or we use specifically to prevent the spread of the virus, or to prevent you to be contaminated or infected with the virus or even bacteria. No? So we have the most effective control is to eliminate the virus, to eliminate, physically remove the virus or the hazard, in case it's a hazard, in case it's something that you have potentially identified. So another is replace the hazard. In cases that you are trying to experiment on something like similar to what you are you want to eliminate, you can replace it, substitution, or substitute to a lower type of a manageable type of potential hazard. Another one is engineering controls. No? So you need to isolate people from the hazard. So these are what we see now on malls, on coffee shops, on offices, is to engineering controls. We are using what we use the UV lights, the HEPA filters, the barriers, okay, and the foot bath, no. So those are engineering controls that we install to our buildings, no, to in order to prevent the spread or to prevent the virus to spread, no. Another is the administrative control. These are the way people work. So this is the washing of hands, uh, the physical distancing, so and using certain protocols before going to the office. So those are administrative controls, like we only let 50% of the people go inside the offices. So those are administrative controls. Or like you cannot eat with one another, or you just eat by yourself. So those are another administrative controls. The least effective is the PPE. So that is the protect the workers with personal protective equipment. So that is the least effective. Because once your PPE is removed, you are physically exposed to the virus. So that is why we are using face mask then a face shield, because our protection is doubled rather than one protection. The face mask, if you accidentally remove your face mask, you have a face shield that will temporarily, or a barrier that will prevent the virus to for you to inhale the virus, or for you to to get contact with the virus. So that is the purpose of the face shield. So it is a very you are exposing yourself to risk, no, if you don't observe, or if you don't uh, use the engineering control first to protect yourself, and you only rely on the PPE. Okay, what I'm saying is that if you are going out to a mall, no, or to do shopping or grocery, make sure that you are observing all of the engineering, administrative, and the PPE on going out. Okay, so what I'm saying is, if you will be going to uh, eat outside, if you will going to eat outside, and you will remove your PPE, your face shield, you are eventually exposed to the virus. Okay? You are exposed to the virus. Even though there's a person that is 3 feet away from you, or 10 feet away from you, the protection is zero. You are now not protected. But if there is a uh, barrier between you and the other person, you might be protected. You might be protected, but it's not 100% because you don't have a PPE. Okay? So it means that you need to observe all of these three in order to protect yourself. So what I'm saying this because right now there is a lot of cases in the Philippines. That is why I am telling you that these three controls that we are now using, you should properly observe this. No, if you will remove your face mask inside a restaurant, you are suspected to be exposed to someone that is infected by the virus. Okay, so it's not wise to do it, to eat inside a restaurant, or if you want to eat outside, make sure that you are alone on the table and it's an outdoor dining space, and you are with a person that you trust that he or she is not infected. Even it means that you trust him or her that he is not infected because you always see him. You are living with that person in the same house. No? So those are the things that you You need to make sure that you are observing when you go out. No? And now we go to the requirements to contain risk group 3 organism. What are the requirements? The laboratory staff must be fully trained in handling of pathogenic and other hazardous material, in the use of safety equipment, disposal techniques, handling of contaminated waste, and emergency response. No? So these are the requirements. You need to be properly trained, no, to in order to work inside this type of organism, the risk group 3 organism. Standard operating procedures must be based on a visible spot. So this is another requirement. SOPs, or the administrative controls, you must properly observe all of these administrative controls if you will work on a risk group 3. Equipment must include an autoclave and certified HEPA filter and class 2 biological safety cabinet. So these are the most important, or these are 3 important things that you need to install as engineering controls in your laboratories to handle a risk group 3 organism. All activities involving infectious material to be conducted in a biological safety cabinet or other appropriate combination of personal protective and physical containment devices. No? So the best way to manipulate or deactivate the virus is inside a biological safety cabinet, no? And with PPEs and on a containment device. Okay? So personal protective equipment should include head covers and dedicated footwear, gloves, appropriate respiratory protection. So these are main requirements in working on a risk group 3 organism, specialized design and construction of laboratory. So that is why there are specific layouts or specific designs for this type of laboratories for you to understand that we need this design to protect the users. On specific air room pressure must be negative at all times, no recirculation, HEPA filtration must be used. On some areas of a COVID testing laboratories, there are what you call negative pressure rooms. And those negative pressure rooms, before the air will go out to the environment, it should pass through a HEPA filter. So the CDC, or Center for Disease Control and Prevention, issued a guidelines, no? The interim laboratories biosafety guidelines for handling and processing specimens associated with coronavirus disease or COVID-19. So these guidelines was issued by the CDC in environmental specimen testing. It says that procedures that concentrate virus such as precipitation or membrane filtration can be performed in a BSL-2 laboratory with unidirectional airflow and BSL-3 precautions, including respiratory protection and designated work area for donning and doffing PPE. The donning and doffing of PPE space should not be in the workplace, and work should be performed in a certified Class 2 biosafety cabinet. As you can see, the explanation, the guidelines explain that people working in these laboratories should have a PPE and should wear the PPE on a separate room from the laboratory itself. So the laboratory should be a biosafety level 2 and BSL-3 precautions. No? It means that the way that you will handle the viruses, you will be using the BSL-3 precautions. So the WHO also issued a guideline on February 12, 2020. The WHO Laboratory Biosafety Guidance related to novel coronavirus. In the initial process before inactivation of all the specimens should take place in a validated biological safety cabinet or primary containment device. Okay, so it means that if you are handling the virus before inactivation, you will be doing it inside a biosafety cabinet. Non-propagative diagnostic laboratory work like sequencing on NAAT should be conducted at facilities and procedures equivalent to BSL-2, and propagative work, isolation, the virus culture or isolation of the virus or neutralization assays at a containment laboratory with inward directional flow, which is BSL-3. So if you're doing culture of the virus or neutralization assays, you will do it on a BSL-3. So in the WHO also uh, uh, issued a guidance in the facility design, like the ample design and designated hand washing basin must be provided with appropriate restriction to access. So there should be ample hand wash basin. Doors must be appropriately labeled. Laboratory walls, floors, and furniture must be smooth, easy to clean, impermeable to liquids, and resistant to chemicals and disinfectant. Normally used in laboratory. Okay, so laboratory ventilation were provided including heating, cooling system, especially fans, local cooling split system, air conditioning units, especially when retrofitted, should ensure airflows do not compromise safe work. Consideration must be made resultant airflow speed and direction. Turbulent airflow should be avoided. This applies also to natural ventilation. So it specifically says that the air conditioning unit, no, should be should have a resultant airflow speed and direction, and turbulent airflow should be avoided. So laboratory space and facilities must be adequate and appropriate for safe handling and storage of infectious and other hazardous materials such as chemicals and solvent. So another one is facility design. Facilities for eating and drinking must be provided outside the laboratory. So you cannot eat inside the lab. First aid facilities should be accessible, and appropriate methods of decontamination of waste. And for example, disinfectants and autoclave must be available in proximity of the laboratory. So you need to have a decontamination system. So using autoclave and disinfectants. The management of waste must be considered in the design. Safety system must cover for fire, electrical emergencies, and incident response facilities based on risk assessment. There must be a reliable, adequate electricity supply for lighting and to permit fire exit. So, as an requirement, you should have a secondary electrical source, which is a generator, in order to protect the people inside the facility. Because in cases there will be loss of pressure, the laboratory will be compromised. No? The standard of the laboratory will be compromised if the pressure differential will be shut down because of lack of electricity. So you need to identify areas that should be supported by uninterrupted power supply. So emergency situation must be considered in the design as indicated in local risk assessment, and should include geographical and meteorological context. So you should also understand the uh, the the assessments that are uh, generated by the users, or formulated by the users, no, so that you will design the facility properly. Okay, so one of the assessment is the laboratory location suited for the type of for the purpose, no? So you will not locate the laboratory on a place that will cause harm to the environment or the people that are living with near that particular laboratory. Okay, so that is also part of the risk assessment. In the Philippines, we also have our own uh, guidelines. So I will discuss the guidelines issued by the Philippines. So this guidelines was issued by the RITM and the Department of Health. No, so the molecular diagnostic laboratory in the Philippines. Uh, so so the discovery of the polymerase chain reaction in the 1980s proved to be a powerful breakthrough in genetics studies in molecular diagnostic using in the PCR, DNA, or RNA, and can be quantified and be used to detect the presence of significant viruses, bacteria, and cell types. No? In PCR testing, it is highly complex. Specialized machines for PCR required specialized airflow systems to ensure that the virus do not remain in the apparatus and inadvertently infect persons running the test. Given the complex nature of this process, the safety of the laboratory personnel, collected samples, and the immediate testing environment is of the highest importance. So conforming with the principles of biosafety is greatly recommended to avoid occurrence of laboratory-based laboratory-acquired infection. So the biosafety level of a laboratory is globally standardized and is assessed based on the pathogens and the ability of such pathogens to infect humans are allowed to be processed within the facility. Usually a biosafety level 2 laboratory is used for common pathogens. So the guidelines of the DOH RITM specifically says that a BSL-2 laboratory is sufficient to handle this type of pathogens. Okay, so there are four requirements to establish this type of laboratory. One requirement is for you to have a laboratory facility that is compliant with the DOH standard, personnel that are trained to use the type of laboratory, and you pass the quality of test, no, that you need to do inside this laboratory. It means that there is a examination or there is a simulation that will identify if you pass the quality or the test that the DOH is establishing. Equipment requirement and maintenance. So you need to have you need to install the proper equipment and you need to have a proper maintenance for the equipment. So the laboratory facility must be a biosafety level 2 facility with at least 3 rooms. Now, the first room is the pre-PCR room, which is the inactivation and the RNA extraction of the sample. So in this room, this is where the virus is inactivated and then the RNA is extracted as this room will be used. No? The reagent preparation room is the second room, which is where the mixing of the reagent, and the PCR room, which is where the real-time PCR machine are permanently stored. So there are 3 basic rooms that you need to install or you need to include in your design. Another is the basic personal competence, in which should have a graduate of the person should have a graduate of 4-year science course, medical tech, biology, biotechnology, molecular biology, and related courses, and has training in skills on PCR and biosafety practices. So there is what you call an in-house biomedical engineer that can handle biomedical equipment maintenance and must be constantly available to support the PCR laboratory operations. Number 3 is quality assurance. No? So the laboratory should have established quality assurance protocols that ensure accurate and reliable results. No? So that is part of the quality assurance test. No? That you will always provide accurate result, including showing evidence of proficiency and performing molecular diagnostic, regular external audits, and other external validation activities. And number 4 is the equipment requirement and maintenance. We have for the pre-PCR room, you need to have a biosafety cabinet, microcentrifuge, and other equipment. For the reagent preparation, you need to have a PCR cabinet or PCR hoods and other equipment. And for the PCR room, you need to have a real-time PCR machine and other equipment. So, periodic maintenance and calibration of equipment is extremely necessary to ensure safety and use of efficiency of this machine. So this is the general notes for the Rtpcr requirements. No, so the door should be at least 1 meter. Windows should have external. You should have should be tempered glass. No, and fixed. All walls partition must be structurally sound, sturdy, impervious to waterproof, impermeable materials, easy to clean with antibacterial, antifungicidal, chemical-resistant finishes. So these are specific requirements for walls, ceilings, and floor. And the interior walls must be floor-to-floor height to prevent cross-contamination and for fire safety compartmentalization. So the interior partition should be floor-to-floor height. So exhaust system, so you need at least 12 air exchange per hour and must be directed away from people and adjacent structure. And the PCR room exhaust should be at least 6 air exchange. And the reagent preparation should be positive and shall have a filtered air supply of 90 to 95% efficiency. So it means that the PCR room is a clean room. So addition exhaust requirement to be considered if the area has an adjacent building. Stack should have a gooseneck and a cup, and it should at least 3 meters higher than the highest point of the roof of or adjacent building. So in cases that you will be building a molecular lab for COVID on a ground floor and the building is 4-story, you need to put your stack, your exhaust stack, 3 meters above the highest floor of the building. So in case of this, you have a 4-story building, you need to put your exhaust stack 3 meters above the last floor, which is the 4th floor, and that should extend at least 3 meters. So you need to put magnehelic gauge to monitor negative pressure for specimen receiving in specimen handling room. And the air conditioning should be split type. It should be directed away from safety cabinets. The pass box for internal pass box should be 30 by 30 centimeter. And for specimen receiving pass box, it should be 40 by 40 centimeter. All plans and drawing requirements as architectural, civil, electrical, lighting, and power, sanitary, and plumbing, and mechanical, and other related trades should be in accordance with the relevant existing codes of the Philippines as applicable. Installation of intercom is recommended. Provision for toilet and other amenities for laboratory staff should be located outside but easily accessible to prevent contamination. So the design philosophy is to reduce risk with a combination of redundant administrative controls and engineering controls. So this is one design philosophy by Dr. Chua Tekmin. And another philosophy is to keep it simple and safe. It is by Mr. Trong Ted. So that's the first part of our that is the first part of our